Всем привет. Меня зовут Matthias, я из Германии, and that's unfortunately that moment when I have to switch to English. So one fact that I must admit, I'm quite lazy. But that's not so bad, because as a software developer, it makes you being interested in automation. So taking just some repetitive task, putting it into some algorithm, and after you're done, you have some more free time. Sometimes, of course, it can also turn out otherwise, and something different. But today, in particular, I'm going to talk about build automation. And build automation is basically the process of automating the build of a software. So implementing certain build steps, like cleaning the repository, compiling the solution, packing artifacts. But automation is not the only goal there. It's also about eliminating the chance of human error. So every time you automate something, it improves determinism. And just to show how complex build automation can be, that is taken from the Roslyn repository. So that all belongs to the build. Not only, those are just the scripts, and you see it's quite complex. So we have build utils.ps1, then also for shell. The build.ps1 here, right here, it's approximately like 500 lines of code, last time I checked. So builds can become very complex sometimes. And what we're using in build automation are mostly build tools. So something like Docker to do some containers. MSBuild, I guess many of you are familiar with that. Command line, XUnit, NUnit. Anyone has an idea what this icon means? Okay, that's open cover. Have you heard? That's for executing coverage with your tests, and then just to find out which lines are covered by your tests. So also a very nice tool that you may want to use in your build script. That's Paket down here, also not so familiar, but just for your information. So, and as a single developer, you may just put calls to those tools in something like a build script, PowerShell, shell, whatever. But as soon as you're part of a team, you probably want to use something like that. A build server allows us to keep track of changes in our team. So on every commit, your whole build chain can be executed automatically. So usually all of those build servers just provide some kind of UI, and you would implement all the necessary build steps that you're interested in through the UI. But there are some problems with that. The first and the major one is that with build servers and just having the configuration on the build server, it's hard to execute the build locally. So you are always forced to commit something new, execute it on the build server, maybe even wait because it's occupied by some of your other colleagues. Or maybe you're even paying for the service because it's a cloud agent or something. So this can get complicated. Also, you can experience some kind of login experience when you're using, for instance, Jenkins, and at some point you decide, okay, I want to switch to Bitrise. There's usually no tool available which helps you to migrate because they have individual configurations. To solve that, developers invented build systems. And in a build system, the main idea is to do tool orchestration. That's, of course, also something that a build server does, but it is more local. So with the primary goal of being able to build just everywhere. So on your local machine, on your colleague's machine, on the build server, just everywhere. Usually those have just one single bootstrapping script that you just invoke for every platform, and then you're good to go. Another thing that improves is the feedback cycle I was talking about. So usually you can do, like I said, build it on your local machine. Sometimes you're even able to just invoke, let's say, the last build step. Let's say you have a build that lasts for 1 hour, and then you could just execute the last step of those. It also provides a minimal coupling, because on the build server you would just then invoke that single script, and that's it. And another thing is with build servers, it's quite hard to version those things. So sometimes there are approaches, but they are sometimes also cumbersome to use. Sometimes versioning is possible, but branching is seriously something that most of the time doesn't work. So for instance, if you're working on master branch, you're creating a new one, changing something on the script, then usually the script only works with one of those two branches. And having build systems, this is by default within your repository and versioned alongside the rest of the code. However, I must say, a build system doesn't totally replace a build server. So you still want to use, or at least I would advise to use both of them. A build server can help you with investigating certain issues by merging. They also capture historical data about tests you're executing and other stuff. So looking at the .NET ecosystem, there are plenty of build systems already, so quite a big choice there. And at the beginning, I want to concentrate on MSBuild and NAND. Both of them are XML-based build systems. So who's familiar with using MSBuild as a build system? Maybe raise hands. Okay, most of the people. So who thinks MSBuild is a handy tool for implementing? Yeah, good one. So actually, I had a lot of talks about that. So actually, it depends. It can be that it's quite handy, but that's mostly if you're talking about compiling the project itself. So for instance, if you're very close to the project model itself, if you want to execute certain things before the actual compile target is executed, if you want to do code generation, that's usually something that fits very nicely into MSBuild. However, all the rest, like invoking command line tools or what else, packing artifacts and so on, that's usually not what you want to put in MSBuild. So this is a conditional path concatenation. And as you see, the condition is quite hidden inside that whole XML. So it's in C# you would just do path.combine. In MSBuild, it's like 6 lines of code. So it can get quite cumbersome. The next category are the non-C# based tools. And it doesn't really matter, or okay, Fake, for everyone who doesn't know, Fake is based on F#, Pisaki on PowerShell, Rake with Ruby as background language, and Gradle JavaScript. And so, it doesn't really matter which one of those you use. I think there are two kinds of different situations. If you're using that, then the first possibility is maybe you're using the related language already in your builds, in your project. Then I have to say everything's fine. You just continue doing so if you're happy with that. However, if you're not using any of those languages, but you decide to use them, then there are two problems. The first one, if you dedicate just one single person to manage the builds, to punish them, it can be that when he's on vacation or gets hit by a bus, you become a serious problem, like a bottleneck, and you keep pushing, working on the build for some reason. The other possibility is that you decide, okay, let's invite all the people to manage the build, but in that case, you're putting additional complexity to your whole project just for the sake of managing the build, which can also get quite costly, gets a new requirement for everyone who's joining the team, takes some time. And so the last category are the C# based. And currently there's only, at least from my perspective, there's only one which is really mature, which is Cake. And that's really attractive because it uses C# as some kind of, or Cake is actually a superset of C#. So let's look at a simple example in Cake. What you do in the first is just to parse something from the command line, so you can either pass the target as command line argument or use just the default. The next few lines are actually a statement. I hope you can see that. It's like a scripting approach here. You define just a target default, which does something, printing out hello, and then invoking that target. So very simple, actually. No class definitions or anything. However, I used Cake for some time, and there are some interesting things I want to point out. So in this case, we have a task which is dependent on the initialization, right? Anyone knows what's wrong with that? It's a string, yeah, but a more serious thing here. I mean, not only string, but there's an actual error. You see, it's initialization with Z and S, which can happen. So this actually throws an exception in runtime, but you don't notice that during design time. A second example. So we still have that task, and we have a class definition. The class definition itself is possible, I can tell you, but do you recognize any other issue here? So it's mostly about calling information in those two places. Do you think that compiles? Who think that compiles? Raise hands, maybe. Who thinks it doesn't compile? Okay, for what reason? Any idea? The static is not a problem here.
In task default,
yes.
Information is part of Cake
DSL. Yes. What you have to do, that's right. What you have to do is to pass a context, and that context is quite hidden. So they do some kind of code generation behind the scenes. That thing is hidden, and you really have to call information on that context thing. So information is actually an extension method to that. And last but not least, that's just a personal observation. For Cake, Visual Studio Code is still one of the preferred, I think, IDEs because it provides the deepest tooling. So they have auto-completion for a few days there, working on that for several times. So for people, who's using Cake actually? Okay, and what IDE do you use? VS Code, yeah, I guess that. All right, so that's a bunch of tools we have, and as if there weren't enough, I'm just proposing another option today, which is called NUKE, and dedicated to actual C# developers. And I started with that approximately like 8 months ago. And what I'm going to show you is some very intensive live demoing, so I hope everything works. First, I'm going to start with setup and basic execution. All right, so first, just for information, there's just one solution I have here with a simple class library. Nothing serious about that. That's the related folder. You don't need to actually see that. And the first thing you have to do when you want to use NUKE, I'm going to leave that mode, is to go to the repository and copy one of the install steps. So we provide them for PowerShell and for Bash, depending on what operating system you're working. And that's something I already have copied here, and let's execute that. The first the script is going to tell you is that it found some sample solution file, which is the one it's going to use. In case there are multiple solution files, then you're going to be asked which one you want to use as default. That's helpful at a later time, but you don't really need to actually use that. So if you have multiple solutions that you really need, you can do that too. So no problem with that. The second choice that you're going to be asked is whether you want to use the .NET Core tooling or .NET Framework. That doesn't mean that you can, with the .NET Core tooling, only compile .NET Core projects. It's only about the choice for the build project that we're going to produce. So even with that tooling, you can still compile a solution full of .NET Framework projects. All right, so I'm going to use that. Next question is which version you want to use. So by default, it always pins to the latest available NUKE version. So you can also accept that. Then the place where you want to put the build project actually, and how you want to name it. So after you're done with that, it tells you, okay, build project generated, build scripts generated, and added to solution. And we can directly check that. Let's go here. It tells us, okay, solution file has been modified, just reload. And as you see on the left, there's a build project that has been added. And just for a second, we will check what other modifications have been done. So the solution file we checked. The NUKE file, let's look into that, actually just keeps a reference to the solution that we selected. And then you have two build scripts for the bootstrapping for PowerShell and Shell on Linux. And the build project plus a default build.cs, which we are going to check right now. So we can execute build.ps1 and just let's, for the first time, just append help there. So in the background, it's already compiling that build project for us. Right? You see that here. And afterwards, we're going to be we are presented with some of the help text. So a version of NUKE, okay. Then the default, the already defined targets, which are in the build.cs, which we're going to see in a minute. And there you have like clean task, restore task, compiles also the default. And it depends, those are only the direct dependencies. It depends on restore, restore on clean, and so on. And we have a bunch of other default parameters which you can use, we will see in a minute. One of them is target, and we could just say compile, although it is the standard actually. But let's just execute. So you see restore is executed, compile, clean was skipped. So for what reason? Let's see. Before I go deeper into how the targets are defined, there's one very interesting thing. NUKE is defined just as a console application. So you see we have a public static in main here, which is then just executing the build, passing the type for the actual build, plus the default target. And that actually allows you to just set a breakpoint there. And let's see how easy debugging is. And you're going to stop there, just like that. Of course, later also in the targets that you define. But let's jump into the clean target. So as you've seen, it was skipped by default. That is just for safety reasons, so that we don't accidentally delete some of your files. So you just remove that one line. And what you also notice is that a target is actually not a string anymore, like in many of the other build systems. It's actually a property that is using an expression-bodied expression, returning a delegate. And just because I was asked quite a lot of times, so this thing is a ligature for everyone who doesn't know. And it and it uses the FireCode font. So if you're interested, I really like that, but just for explanation. And so, how is that clean target actually implemented? The first step is to delete some directories. And if you look closer, it looks for all the bin and obj files, so just to have a really clean repository there. One also interesting thing here is the source directory. And if you call the help for that, it's a bit small, but I can just read it. It tells its default path to either src or source, actually, because I've seen a lot of repositories where either source or src is the default for the source directory. You don't need to use that, but if it matches your actual configuration, then you just can. In case both exist, we just throw an exception, or if none exists. The second is ensure clean directory, so that will just make sure that there's a directory, but it's clean, of course. Output directory also defaults just to the output directory within your root directory of the repository. So quite easy. The second thing is the restore target, which is also already defined. It depends on the clean target. And actually, you also see, like, if, let's say, I mistype that, then you get an actual compile error. So something like I have shown in Cake is purely not possible because the type system helps you. Can also rename or something, of course. And the restore target just invokes .NET restore here, together with something that is called default.NET restore. And that's actually a default setting we provide for many tools, not for all, but for some of them. And let's just invoke the restore target again. What you see here, that's the actual invocation that is done from the call. What you see here, that it not only calls .NET exe restore, but also passes a reference to the solution file. And that happens automatically. So in this case, it might be not so astonishing, but we will see in the next example that it can actually have that it can help actually with many things. So with the compile, it's very similar. We depend on restore, and we call .NET build also another time with a default setting. So let's see what compile does. In compile, you see it's not only the solution file, but we also pass configuration as debug and the no restore parameter. So if you want to change the configuration, you can do that just from outside. Let's say we do configuration is release now. So without actually doing anything with the call, it automatically gets injected into that particular invocation. Now another thing is, who knows about Git version? Okay, it's a small, for everyone who doesn't know, it's a small tool that helps you to create meaningful semantic versions based on your Git commit history. So at one time you might tag your commit as version 1.0, and already the next commit gets a new version. So that's very helpful. And what you can do is, right here, we can just define, I will close the other stuff, or maybe make it this way. Define a field, which is using Git version. That automatically gets populated during startup. And now, just with defining that little field, we can re-invoke execution again. And you will see that the compile step actually has a lot more that has been added automatically, like the assembly version, file version, information version, and so on. And that gets actually really interesting as soon as you have something like, let's see here, no, please not, open cover tasks. For OpenCover, there are a lot of default values that are good to have just by default because they are good practice, like ignoring all tests because you don't want to use that for your coverage as well. So tests shouldn't influence coverage data. All right, next thing. Actually, I forgot to switch to my presentation meanwhile. So we are right here currently. We've done the first three here, clean, restore, and compile. The next we're going to do is pack and push as a target. So let's go back. I will just copy that. Good developer. Using pack, referencing compile. And for pack, we of course have something similar. You just call .NET pack. In this case, also there is a default setting. And let's say I'm not quite sufficient. I'm not quite happy with the default, because if we look at it, it's maybe not so nice to see. But let's look at it. There's one call which says set the output directory to the output directory that we already talked about, which is cleaned in the clean task. So let's say that's not what I want, but I want to set it to something different. You can totally do that, because for each of those settings, there's a builder pattern implemented. So and you can just say set output directory and use the output directory. And let's say we want to put it in some subfolder inside that output directory. So then you can do just that. So it's a little magic happening here, because we are overloading that division operator. But for that purpose, it's totally neat from my perspective, because it abstracts away the need for differentiating between slash and backslash depending on your platform you're working on. And so let's invoke that too. I'm going to write this at the end. Target pack. And let's look into that folder. So we have the output folder right here. Pack is executed. We also see in this case also the version is passed automatically. No build, includes symbols, a lot of defaults that you don't have to use. You can reset them, but hopefully it's useful. So the package has been created. All right. Next thing is the push target. Copying again. Pack. And in this case, we can again use this globbing mechanism that I've shown you earlier. So we can just do, let's make it a little higher, glob files based from, we essentially want the same that's standing right here, right? So we can, I don't know, just extract a property, let's say, name it packages directory. That you can convert to string. I think it's in some places it's more appropriate. Now we can actually use that anywhere, right? And we are just doing that, packages directory, and we're looking for all the NUGget packages that have been created. Introducing a variable with that, so packages, and last but not least, iterating over that and just call something like .NET NuGet push. In this case, I think there's no default, but we can set it to use that particular package we're currently iterating over. Then in my case, I'm going to push it to myget. So set the source to, let's see where the myget feed is. This one, that's the feed. And last but not least, setting the API key, which is I have to copy from over here. Put it there, right? Do you want to do that? Rather not, yeah. So, of course, this is not the way how I would do it, but let's first introduce a field with that. So we are using myget API key. That was not what I wanted. Again, field initializer, yeah, okay. myget API key. and let's go here. Of course, I don't want to write that and commit it to my repository. Makes no sense. However, what you can do is putting an attribute onto that field, and that attribute allows you to pass the value from the outside automatically. So for that purpose, just to show it, let's call help again. By the way, you don't need to remove all that other stuff. If you call help, then just help is executed and you can just leave the rest. So we see myGet API key has been added as a parameter here. You can even provide a description if you want. In this case, I don't want too much noise. And you can actually pass that to the push target. So let's do this. Or maybe let's don't do this. Let's execute push like it is. Okay, and of course it should fail, right? Damn it. So no API key was provided. But that behavior we just experienced is not something we want, I guess. It's too late. So what actually should happen that upfront, prior to execution, we want to be notified that the myGet key is not available. And you can totally do that. Requires, and then just myGet key is unequal to null. And actually, you can also write just that because it checks for the field being null. And in that case, if we repeat that mistake, so no target was executed, not even clean or something, which is not reliant on myGet key. But it tells us, okay, the myGet key has not been applied from the outside. By the way, you not only can provide it from the command line as an argument, but also as environment variable. Totally possible. And so, to make it actually work, finally, push myGet, no, myGet API key. Nope. There was the key. Okay, it's running. In the meantime, I just want to show you there's no package there currently. Yeah, that's the feed, and hopefully in a second we will see something. So the build went through, everything executed, and depending on how fast myGet works, but it's a very nice thing, we will see in a minute that this package should appear here. There it is. Okay. Whew. Worst part is over. All right, let's switch back to my slides. One thing I really want to point out here is that this works with any IDE. There's nothing involved like an extension or something. It's just a simple C# console application without requiring anything to learn about debugging or something, which I hope is helpful. So you want to introduce a variable, extract something, you just use your IDE. You want to debug, set a breakpoint. And you want to find out about a certain method, you can just use go to declaration, decompiler or something. Okay, now I want to go back, take a step back to the tools slide from before. So there are a lot of tools out there, right? I guess everyone agrees. And having this dedicated API that I was using for NuGet push and .NET and so on, it can be helpful. It's very easy to use, I guess. But I guess you also want to use that for any of your tools. Sometimes maybe process start is just enough, and you can use string interpolation for that. But it's not the nicest way you can go. And so there are many tools out there. Maybe you even have one that is only private to your company or something that you want to have a similar API for. And I have a solution for that. So how do we get support for all the tools out there? That's using some code generation, Kotick. No, it's actually code generation what I want to utilize. And the idea of code generation is basically as follows. So at some place you have a reference. If it's written as PDF or an online documentation, you have a reference there. And you just take that reference, extract some metadata, which we will do in a second, and from that metadata you're generating the API, the actual code. So let's do that. Let's say the first thing you have to do for this in order to work is add another dependency. I will just quickly do that. It's the code generation package. Code generation package, come on. Okay, it should be working already. And let's just create another target, which is called generate. And from here we call it the code generator. And the metadata directory, we will create that metadata in a second, but the directory from where the metadata is taken, let's say it's from the build directory, so that's inside the build project. That's a property we inherit from the base class, build directory. And also let's generate it, that's all right, into the same directory. Now the first time you execute that, you can remove that, target generate. The first time you execute that, something will happen. you don't see it currently, but in your project there's a schema.json file created. And that now helps us to have a little bit more of support while authoring that metadata. So let's go and build some metadata. I will just create a file which is called like random tool, anything you want. And I hope it works in Visual Studio. If not, I will switch to VS Code. But that's, I don't know, because of the IDE. What we have to do as first step is just to provide a reference to that schema file. So we're doing something like schema.json. And that hopefully gives us, no, not here, but hopefully in VS Code. Gives us auto-completion. So Visual Studio you have to sometimes just restart, no idea. Okay. In Visual Studio? Ah. Yeah, I don't know how to select that now. Maybe reload. Ah, now it works. Very nice. I like that. All right, cool. So first you're going to tell it its name. I know it can be derived from the actual file name, but I can assure you there's a reason for that. Next is we're going to define some task. And now I will just write something that, some parts we should skip here, but let's say we have, at one point, we want to define all the arguments that can be passed to our command line tools, like, for instance, help or something. So, or like the build command for .NET exe. So in this case, that all goes into the properties property. You just say the name, which is the C# part of the API, and you could just say, okay, we have an argument that's called force. It has a type of bool, and what actually should be outputted to the console during the invocation is /force, let's say. Okay, that's just an example for one Boolean parameter. Another thing I want to try here is, let's say we have a bunch of items that we want to pass. In that case, the type is, well, it's not quite language agnostic, but almost. So you can say it's a list of strings. And that formats to something like items and then the value. Value gets replaced with the actual value in the object. And because it's a list, you may also want to define something like a separator. So let's, in this case, just use the plus. And as last example, another one, which is called kind type. Let's use something type safe, and enumeration actually, say something like my kind, and it formats to, come on, kind value. So we have defined that thing too. You can actually do that in the metadata too. So it's enumeration. It has a name, which is my kind, so it should be basically the same as you used before. And some values, we can use something like first and second. So that's the metadata we have written for our random tool, let's say. Okay, the next thing you do is, of course, execute generation again. Okay, and it tells us random tool has been processed. Let's go back to Visual Studio, to our build. And copy that, copycat, target foo. And what you see here, even if it's very small, a random tool.generated.cs file has been created. And what's in there is actually just a very similar API to the rest. So you have a class-defined random tool task. You can call random tool on that. You can, and I will do this as a trick, so we will set the executable that is executed just to echo for the purpose of demonstration, because it's the easiest thing to do here. So just to echo. And then we could say, what was the first? Enable force, we could say. We could say set items to A, B. In the next step, because it's the builder pattern again, you could say, okay, remove items B. Add items, let's make it really complicated. Add item C. And finally, set kind. In this case, you're getting presented, let's make it bring up a little bit higher. You see that we also have auto-completion for just the meaningful values at this point. We can select first or second. And now, let's just execute that. So it's called foo. And you see, to that echo command line, we have passed force, we have passed the items. So first we added A and B, then removed B, then added C. And we also have the kind printed out there. There's a bug? No. No, where exactly? That's just the output from echo, yeah. Yeah. Okay, about that code generation. What is actually generated during that process? It's the invocation itself. So it checks for non-zero exit code, but you can replace that, of course. That's not meaningful to do that for any tool, of course. It also generates tool resolution. So for all of the tools that are coming from NUKE packages, you can just define the package ID plus the name of the executable, and it will take care to actually resolve that path for you. You can resolve from the path environment or from an actual environment variable. Third thing is argument configuration. That's the thing you have seen in action with the set kind, add items, and so on. They're also available for dictionaries, so one-to-one mappings, but also for one-to-many mappings, like iLookup, for instance. We provide XML documentation. I actually haven't shown that, but if you, for instance, go onto that set output directory and you invoke the, or let's go onto .NET Pack, it's actually the very same help text that is on the website of .NET Pack. So it tells like something, the .NET Pack command and so on, blah, blah, blah. That's actually, no. That's actually the same text. XML and assertions. Something I didn't show here, but you can make sure that an actual argument is a dictionary or null, or actually a dictionary, it should exist, and so on. That was it. All right. I can still show something. What can I show? Or are there any? No. What can I show? I'm finished way too early. So yeah, one thing is extensibility is a very serious topic, I guess, for a build system. And there, come on, internet, don't leave me. That's the website, and we still provide documentation, even though you have that on your IntelliSense. Some of the classes are marked as entries, so good to know about them at some point, like a logger or process invocation. Path construction, what you have seen with the division operator. And some meaningful way to access the bunch of CI servers that are around there. And at the very last, you also see that there's a common way to add add-ons to that documentation website. It's actually just an entry in a YAML file that will take care that this particular project is also put on the website, and it's just discoverable for all the add-ins that might occur at some point. Okay, maybe one more thing that I can show for the properties here. So as I said, there's also the possibility to add something like properties. Let's call it properties directly. And then it's the type dictionary from string to, we can also say something like int. That's also possible. And then it would just say /p, for instance, the value. And because those are always pairs, you also have to define something like an item format, where you just say it's the key equals value. And that allows you, let's compile that again. Generate. And that will allow you to do a similar thing just with properties. So you can say set property, key, and no, set property, like that. And then just the key and a value, like 1. All right. One thing I also didn't show, which is interesting to see, is the graph argument that you can pass. Or maybe not. Let's delete some parts of that graph again. Come on. String adds something with generated code. Shouldn't have done that. Okay, again. Pray God that this works. Okay, I know we still have this part. I will shoot myself if that doesn't work now. Okay. So at some point, if you want to find out how your dependencies are defined, you can just invoke that. Unfortunately, it's just HTML. I wish I could bring that to the console, but drawing graphs in the console is, I guess, quite complicated. And I haven't found a way, except some library in Python. So maybe at one point we can do that. But let's say you will also find out about certain cases, like, for instance, let's say the clean target, we just accidentally said it's dependent on pack. Then this will, of course, also pop up in the HTML file. In the background, just to say, it's mermaid.js, so that's actually not my part. But you see it shows the graph correctly, so you can identify circular dependencies. Of course, that's also outputted on the console if something like that happens, but for diagnosis, I think that's helpful. So one thing I have to say, there are a bunch of people who helped me with the initial development, some of them with the actual design, some of them with the presentation, because it's the first time today. And thanks to them, and that was the official part. Спасибо большое. Okay. Есть вопрос? Microphone is coming.
Namaste. Can I use it for Travis CI?
Sure.
Sure. So what should I do? Just run build sh or what?
Yes.
Yeah. Thank you.
Any other questions? Yes. In the back there.
Thanks for the talk. I have a question. How is MSBuild support implemented? For example, did you write the metadata by your hand, or are you parsing the reference of MSBuild?
Not sure what exactly you mean.
You show the JSON files that are the metadata that is used for generating the code. So all the already written tooling support, for example, .NET build, NUKE restore,
Yes.
MSBuild. How is it implemented? Are you writing JSONs by hand? Are you parsing the reference? Or
usually for that small amount or if the command line tool only provides a small amount and doesn't provide it in a already overseeable schema, I usually do that by hand. But there's one thing that I didn't tell in that matter, and that is that in that metadata, so we can actually go to the MSBuild metadata, we also save a reference which is checked with every generation. So this will actually download the reference that I used to provide the metadata, and it will check if it has changed since the last generation, so that we can easily detect if some tool added a new parameter or removed some or renamed some. So actually, I think it should scale as long as we execute the generation step often enough. Does that answer the question?
Yeah, thank you. And I have another question. Do you have plans for making a cake integration so that people could easily migrate from cake to Nuke? Like detect the cake targets?
So this is not yet pushed, but there is a cake repository on my file system which actually implements the iCake context which we have seen earlier. Of course, I didn't try that with any of the add-ins, or with all of the add-ins, I mean, from Cake, but that allows you to use the existing Cake add-ins and just use them from Nuke. Of course, that's not always meaningful, especially if they are add-ins for command line tools again, but for all that is just compiled using some library to provide a better API, and during NUKE doesn't offer that. You could use the cake add-ins and just use that bridge. In code, you would actually write then something like cake dot and then the usual extension methods like information, what we have seen earlier. That's how you would use that then.
Okay, thank you.
There.
Hello, thank you for your talk. This seems like really a promising tool. And I have a question. Can we implement running of unit tests from this tool? And how can we use some failing scenarios? For example, we need to push or deploy somewhere in case unit tests pass for, like, they give us certain result and fail otherwise. How can we achieve that?
So in that case, I guess you would have the test as a single target plus the deploy as a single target, right?
Yes.
Yes. In this case, you would just express that deploy is dependent on test, and when test fails, of course, deploy is not executed.
Okay, and in case we need a couple of scenarios which would go further in some case and fail otherwise. I mean, so do we need to do some post step logic or something like that?
You would just throw an exception in that case if you, well, you can use actually just C# there.
Yeah, I mean,
Yeah.
our external tool, like that random tool, it could just write to standard output, and it just can, I don't know, return with other than 0 result, and we have to catch that and fail accordingly.
You don't need non-zero exit codes. You don't need to catch them. Because they are in the implementation. I can actually show that. Oh no, I deleted that. But I can show it in some other scenario. Let's see. It's for instance in OpenCover should have that. No, or .NET should have that. .NET generated, and you see in the implementation it checks for a 0 exit code. Is that what you mean? So you don't need to do that by yourself. That's the standard behavior. You can still say in your random tool, okay, I want myself to be responsible for checking the exit code. That's possible. In that case, you will have something like assert execution or something. I don't remember process. That is what's get generated. And then you have to define that method yourself. For that purpose, it's defined as partial, so that you can create a new file and just provide a seam for that particular line of code.
Thank you so much.
Yeah? All right.